All right, I've been asked to do a couple of questions on completing the square. These are some of the trickier ones. You can see I've highlighted about 5 different ones there to do, and I'll just talk you through how to do them and see if we can make a bit of sense of these. So 5c, first of all, I've got x squared plus 5x minus 2. Now, whenever we're doing these, we're going to keep in mind what's our actual goal. Our goal when we're completing the square is to make a perfect square. A squared plus 2ab plus b squared, anything in that form is a perfect square because it can be factorised into the form a plus b all squared. And similarly, if it was a squared, I'm running out of room here already, a squared minus 2ab plus b squared, then that factorises into the form a minus b all squared. So that's always going to be my aim, to make one of those two forms, and then I'll be able to factorise. How do I know to do it? To try and use this method, either the question will say, or I'll look for factors of the n term c that are going to add to make 5, or the b term, in this case that's 5. Clearly I'm not going to find factors of 2 that add to 5. So I go ahead and I create my perfect square. Now this one's got a plus in front of the 5x, so I want to make sure I'm using the term on the right there. I want to try and make that a squared plus 2ab plus b squared. So to get it in the same form, I've already got something squared. Instead of a, it's x squared. My next bit has to be 2, always 2, times the first thing, which was x, multiplied by another number. It still has to equal 5x, which is what it's coming from. I'm just rewriting that 5x in a different form. And the easiest way to see that is if I just take that 5 and divide it by 2, then when it's being multiplied by 2 at the front, those 2's would cancel and I'd still have 5x. The last little step is to add on the b squared, and this is why it's called completing the square, because I'm actually going to complete that perfect square. I have to add on the 5 over 2 term squared. Now I've got something which is a squared plus 2ab plus b squared. The negative 2, well, nothing happened with that. It's still there. But I did cheat a little bit, didn't I? I added on the 5 over 2 squared. I've got an equal sign here at the start that says the line above equals this line. So if I've added on 5 over 2 all squared, I need to subtract the same amount just to make sure that my statements are still equal. Now I'm at this point, it's fairly easy. The first 3 terms, we deliberately chose those because they would factorise into a perfect square. So that's going to be x plus 5 over 2 all squared. I'm just going to clean up the numbers on the right here. When I expand 5 over 2 squared, that's 25 over 4. Top times top, bottom times bottom. And the negative 2, well, I want to write that over 4 as well. 2 is the same as 8 over 4. So now I can get this into what is actually our turning point form. Negative 8 minus another 25 is negative 33 over 4. So if I stopped at that point, I'm in my turning point form. I can see the turning point of this parabola, if I wanted to sketch it, would be negative 5 over 2, negative 33 over 4. So that's one of the reasons why we might complete the square, to get it in the form x minus h all squared plus k. That's in turning point form with the turning point at hk. Now, I can do that in a video because you can go back and watch that again. Let's get back to the task at hand, though, which is to finish factorising this. Well, now I've got something squared minus something else. This is crying out for you to recognise that I've got an opportunity to use our favourite rule in maths, the difference of 2 squares. 33 isn't a perfect square, but I could certainly write it as the square root of 33 squared. 4 is a perfect square, so I can just make that denominator 2, and then when I square it, I definitely now have the difference of 2 squares, so I can write this as x plus 5 over 2 plus root 33 over 2, and x plus 5 over 2 minus root 33 over 2. And you'll notice probably in the book they'll have it 5 plus root 33 all over 2. It's the same thing. X plus 5 minus root 33 all over 2. And if you had it written in either of those forms, I'd give you the marks. You'd have done it correctly. So the only real challenge, when there's an odd number for b, as there was in this case of 5, I end up with a few fractions, and that just makes it a little bit trickier. But not too bad. I'll do h again. I won't provide all the commentary this time. Just see if you can follow the steps as I do 5h, and we'll see how we go. And there you have it. Factorise by completing the square. If I bothered to expand that, I'd get back to x squared minus 9x minus 5 over 2. And that's how you have to do it. You'll notice there when I went from the third line to the fourth line, I just did negative 10 minus 81 was negative 91 over 4 and just wrote it as a squared term straight away, sort of skipping out that little extra line of work that I put in the first one. It's up to you to judge how much of that you can do confidently, but either way you should be able to get to the answer. We're going to question 6 here, so I'm going to have a go at doing 6a, 2x squared plus 12x plus 8. 2x squared plus 12x plus 8. Now this one doesn't have a odd number in the middle term. It's an even number, but it does have a coefficient in front of the x squared term. So before I do anything else, I have to take out a common factor. And in fact, whenever there's an a term that's not 1, a term in front of the x squared, I'm going to take it out even if it's not a common factor. So here I'm going to take out the common factor of 2. I've got x squared plus 6x plus 4. I could go ahead and try and factorise it, but factors of 4 don't add to 6. So I'm just going to complete the square. I'm just going to have that 2 out the front of the brackets. But I still go about it the same way. X squared plus 2 times x. It would have to be a 3 there to make sure it equaled 6x. That tells me what I've got to add on. 3 squared. I already had a plus 4, so I keep that, and then I subtract the 3 squared. All of that was happening inside the brackets. Now, those first 3 terms inside the bracket still factorise. So I've got my outside brackets, and then I've got my x plus 3 all squared. And then plus 4 minus 9, that would be a minus 5. And we can go ahead and finish factorising in here using the difference of 2 squares. X plus 3 plus root 5. And you'll see I won't need those big external brackets, but I'll keep them there for now. X plus 3 minus root 5. Because everything's being multiplied together now, those last external brackets don't need to be there, do they? I can get rid of those too. Whoop, got rid of one too many. Get rid of those. And there we have it. That's our factorised form of 2x squared plus 12x plus 8. Not as bad as it looks. So when you've got a coefficient of x squared that's not 1, take out the common factor first, and then we go ahead and solve it. We've got a couple more to go. I said I was going to do 7d. Let's have a look at that one. Change it up with the exciting rainbow pen. Why not? 4x squared minus 28x plus 12. plus 12. So, coefficient of x squared is 4. So the first thing I'm going to do is take that 4 and put it in front of the brackets and divide everything else by 4. So I'm left with x squared minus 7x plus 3. Well, I can't find factors of 3 that add to negative 7, so I'm going to go for completing the square again. So I want to write it in the form of a perfect square, x squared minus 2 times x times 7. Times 7 over 2. Let me write that again. Getting worried about the extra space I was taking up. Minus 2 times x times 7 over 2. That's still, when I multiply those out, that's still going to equal 7x. That's right. I need to complete the square by adding 7 over 2 squared. I already had the plus 3, and then I can't change what this equation was worth, so I've got to subtract 7 over 2 all squared and close that final bracket. All right, the first 3 terms become a perfect square. It's going to be x to minus there in front of the second term, so it's x minus 7 over 2 all squared. And then if I think about my 7 over 2, when I square that, that's going to be 49 over 4. So I'm going to write my 3 in terms of quarters as well, and of course 3 would be 12 quarters. So I'm just doing that to make sure I can join them together. So I can do my last step where I use my favourite rule in maths, the difference of 2 squares. So I've got x take 7 over 2. You can see I was jumping ahead to the 7 there. X minus 7 over 2 all squared plus 12 minus 49. That'd make it negative 37 over 4. But I want to write it as a perfect square. So I can make that root 37 over 2 squared. And now I can use my difference of 2 squares. So it's 4 x takes 7 over 2 plus root 37 over 2. And x minus 7 over 2 minus root 37 over 2. Lucky last one coming up. The rainbow pen was fun, but maybe it was a bit hard to see. Let's just try a different colour. What have we gone for? Let's try blue. And we've got one more to go. Negative 2x squared plus 10x plus 8. And that was letter, is that an I or a J? It's an I. Negative 2x squared plus 10x minus 8. So 7i negative 2x squared plus 10x minus 8, or was it a plus 8? Plus 8, silly duffer. There we go. All right, again, I want to take out that coefficient as a common factor. This time it's negative 2, so I put negative 2 in front of my brackets. That's going to leave me with x squared minus 5x minus 4. The negative 2 stays out the front. I get it in the form of a perfect square, so it's going to be x squared minus 2 times x multiplied by 5 over 2. That's what I need to multiply 2x by to end up with 5x. To complete the square, I've got to add on that last term that I made, the 5 over 2, and square it. My negative 4 is still there, and I'm not allowed to cheat, so I've got to subtract the 5 over 2 all squared. The negative 2 stays out the front. The first 3 terms, they're a perfect square. That would be x minus 5 over 2 all squared in this case. The negative 5 over 2 squared, that's negative 25 over 4. So my negative 4, I could think of it as negative 16 over 4. I can join those two together. Negative 2, x minus 5 over 2 all squared. Bad habit of mine, sometimes switching the way I write my x's. Apologies for that. Negative 16 minus 25, it's negative 41 over 4. I didn't write it as a perfect square this time, and that's okay as long as I remember to put it into my brackets when I'm doing the difference of 2 squares as root 41 over 2. And then x minus 5 over 2 minus root 41 over 2. And that would be your answer. Remember, why did I have to square root it there? Because in the previous case, when I had negative 37 over 4. I made that root 37 over 2 and squared. So my negative 41 over 4 in that one is exactly the same. Let's just ignore the negative there. Let's just make it the 41 over 4. That's exactly the same as root 41 over 2 all squared. All right, hopefully that was helpful for some of you. Keep the questions coming and keep up your hard work. Good luck. Cheers.